So in this video, we're going to look at finding the distance between 2 points that lie in the coordinate plane. Now, before I go into this equation that will find us the distance between 2 points, I'm going to walk through this graphically, how we would find the distance, and you'll see where that formula comes from, hopefully, by the time we're done. So if I'm given 2 points that lie on a graph or a coordinate plane, I want to find the distance in between them. Basically, what I'm trying to do is I'm trying to find the line segment, however, the line segment that connects those 2 points. The length of that line segment represents the distance in between them. Now, what we're going to do is we're going to make a little triangle right here. So I have my grid. So I'm going to make a triangle that has a vertical leg and it has a horizontal leg. Oh, let's not do green, let's do blue. So I'm looking here at this triangle. Now, notice what kind of triangle we have. We have a right triangle here. And I want to get how long the 2 legs are. Well, looking at your grid to figure out how long the legs are, let's start with the blue leg here. And so how long is the blue leg? Well, I have one side that's at 6, the other side that's at 3. So the length of that side is 6 minus 3. So I have one side length that's 3 units here. My red side, which is based on the y values, I have a y value of 9 and a y value of 6. So the length of that side is 9 minus 6, which happens to also be 3. Now, when we're working with the triangle, especially a right triangle, if I want to find the length of the hypotenuse, we're going to use Pythagorean's theorem, which Pythagorean's theorem says that if I take the 2 legs and square them and add them together, so a squared plus b squared is going to equal c squared. That's Pythagorean's theorem, where a and b are the legs and c is the hypotenuse. Well, a is 3. So I have 3 squared plus b is also 3. And c is our distance, which is d. And so I'd work my way to solve from here. Now 3 squared is 9. So I got 9 plus 3 squared again is 9 equals d to the second power. So 9 plus 9 is 18. So I got 18 equals d squared. To solve for d, I'd have to take that exponent off of the d of 2. So I'd take the square root of both sides. So the square root of 18 is equal to d. And we can simplify the square root of 18 because 18 is 9 times 2. So the square root of 9 times the square root of 2 is equal to d. So d is equal to 3 times the square root of 2. That is the distance for how long that line is. Now, what I want us to do is we're going to actually look here at what it was that we did. So let me take this line here that we have and copy it. And let's paste it. All right, so I have that line right there. Now, what that 3 represented here, which it got cut off a little bit, that 3 was represented by 9 minus 6. That's how I got it, which really those are 2 y numbers. So I have y2 and I have y1 here. So I have y2 minus y1, and then we have plus, and then the other 3 was created by the subtraction of my 2 x numbers, which I have x2 and x1 here. And so we have, the blue was x2 minus x1. And so basically we had this formula where we had y2 minus y1 being squared plus x2 minus x1 being squared is equal to the distance between the 2 points being squared. That is a distance formula. That is going to look very, very similar to the equation we're given here. The only difference is in that equation they already took the square root of everything. So that's where the distance formula comes from. It comes from solving a right triangle using Pythagorean's theorem. Now, let's say I'm not given the graph to use, and I'm just given 2 points. So instead of me making a graph and then using that method, we're just going to use our distance formula. Now, the distance formula between 2 points, you start off by labeling your coordinates. So first coordinate will be x1, y1. The second coordinate will be x2 and y2. And so the distance between the 2 points, distance equals, between 2 coordinates, the square root of x2 minus x1 being squared plus y2 minus y1 being squared. And we're going to plug in our numbers. All right, so d is equal to the square root of, all right, x2 is -7, minus x1 is -5, all that's being squared, plus y2, which is 2, minus y1, which is -3, being squared. Now, you work your way and you start simplifying the insides. So -7 minus -5, that turns into a plus. I end up with -2 being squared plus 2 minus -3, that turns into a plus. That gives me 5 being squared. And so what I have, -2 squared is 4. 5 squared is 25. So I got 4 plus 25 inside that square root. And we have d is equal to the square root of 29. And I can't simplify that radical, so there's my answer.